Welcome to Top Thangs. If you're ready to have your mind blown by some of the most fascinating physics theories out there, you're in the right place. We're about to take a wild ride through the cosmos, exploring concepts that sound like they're straight out of science fiction, but hold on, they're rooted in real science. Let's kick things off with a real head-scratcher. Superdeterminism. This theory throws a curveball at our understanding of cause and effect. Basically, it suggests that everything that has or ever will happen in the universe, including every decision you've ever made, was set in motion at the moment of the Big Bang.
Imagine the universe as a giant pool table. The moment the Big Bang happened, all the billiard balls were set in motion, their paths predetermined from the start.
Now I know what you're thinking. Does that mean I have no free will? Everything is already decided? And that's the million-dollar question, isn't it?
If the universe is just a giant pre-programmed machine, then what does that say about our choices, our desires, our entire lives? This is where things get really interesting.
Superdeterminism challenges us to rethink our place in the grand scheme of things. Are we really just actors following a pre-written script, or is there room for improvisation in this cosmic play? We've all had that eerie feeling, walking into a room and feeling like you've been there before, or having a conversation that seems strangely familiar. That's déjà vu, a French term that literally translates to already seen. It's a phenomenon that's been puzzling philosophers and scientists for centuries. But can physics offer an explanation?
Some physicists believe that déjà vu might be a result of tiny fluctuations in space-time. Imagine the fabric of our universe as a slightly wrinkled sheet. These wrinkles could create small distortions, causing us to experience a moment twice, or at least feel like we have.
Others suggest that déjà vu could be a kind of neurological hiccup, a misfiring of neurons in the brain that creates a false memory. Imagine your brain as a supercomputer processing massive amounts of information. A slight error in the system could easily lead to a feeling of familiarity where none exists.
Whatever the explanation, déjà vu remains one of the most intriguing mysteries of human experience. Is it a glimpse into a parallel universe, a message from our subconscious, or just a quirk of our brains?
Get ready for a real brain twister. Retrocausality flips the script on our understanding of time, suggesting that an event in the future can actually influence an event in the past. It sounds impossible, a violation of the fundamental laws of physics as we know them, and yet the idea has been gaining traction in some corners of theoretical physics.
Think about how strange quantum mechanics already is. Particles seem to exist in multiple states at once, until we observe them, collapsing the wave function. Could it be that the act of observation in the present is actually influencing the past behavior of the particle?
Now I know what you're thinking. Are you saying that we could build a time machine and change the past? Well, hold your horses. Retrocausality is still a highly speculative idea, and we're a long way from sending messages back in time.
If the future can affect the past, then the very notion of cause and effect starts to break down. It challenges us to rethink our linear understanding of time and consider the possibility that the past, present, and future are all intricately interconnected.
Chapter 4. The Many Worlds Interpretation, a universe of infinite possibilities.
Ever wonder what would have happened if you'd taken that other path in life?
The Many Worlds interpretation says that every decision you make, every fork in the road, actually creates a new universe.
In this view, there are countless parallel universes out there, each representing a different outcome of every event that has ever occurred.
Imagine a vast cosmic tree with each branch representing a different possible timeline.
Every time a decision is made, a new branch sprouts, creating a whole new universe where that alternate reality plays out.
It's a mind-boggling concept, but it's one way physicists are trying to make sense of the strangeness of quantum mechanics.
In the quantum world, particles don't just exist in one state. They exist in a superposition of all possible states at once.
It's only when we observe them that they collapse into a single state.
Chapter 5. Loop quantum gravity, quantizing space and time.
For decades, physicists have been trying to reconcile the two pillars of modern physics. Einstein's theory of general relativity, which describes the universe on a massive scale, and quantum mechanics, which governs the realm of the very small.
The problem is these two theories don't play well together.
That's where loop quantum gravity comes in.
It's a bold attempt to rewrite the rules of physics and create a theory of quantum gravity, a theory that can describe the universe at its most fundamental level.
Imagine zooming in on the fabric of space-time, getting smaller and smaller until you reach a point where space-time itself is no longer smooth and continuous, but made up of tiny, interconnected loops.
These loops are like the pixels on your computer screen, the smallest possible units of space-time. Chapter 6. Planck units, the universe's ultimate building blocks.
In the vastness of space and the incredible tininess of the quantum world, we use units of measurement to make sense of it all.
But what happens when we get to the smallest possible scales, the very building blocks of the universe?
That's where Planck units come in.
Named after the physicist Max Planck, these units represent the fundamental limits of measurement in the universe.
We're talking about the Planck length, which is about 10 trillion times smaller than an atom, the Planck time, which is the time it takes for light to travel a single Planck length, and the Planck mass, which is about the mass of a flea crammed into the volume of a single proton.
These units are mind-bogglingly small and incredibly dense, representing the point where our current understanding of physics breaks down.
They're like the pixels in the universe, the smallest possible units of space, time, and matter. Chapter 7.
Could there be more to our universe than meets the eye? Could there be hidden dimensions beyond our perception, realms that exist parallel to our own?
The idea of interdimensional travel has captured the imagination of science fiction writers for decades, but it's also a topic that's being seriously considered by physicists.
Imagine our universe as a flat sheet of paper. Now imagine that there are other sheets of paper, other dimensions stacked on top of ours.
We, as three-dimensional beings, would only be able to perceive and interact with our own sheet. But what if there were ways to fold the paper, to create bridges or wormholes between these dimensions?
String theory, a leading contender for a theory of everything, suggests that there could be as many as 10 dimensions, most of them curled up and hidden from view.
Chapter 8. Wormholes, shortcuts through space and time. If you want to travel to the farthest reaches of the cosmos, you're going to need a shortcut, and that's where wormholes come in.
Imagine space-time as a giant sheet of rubber. Now imagine folding that sheet in half so that two distant points touch. That connection point, that's your wormhole, a tunnel through space-time that could potentially allow for faster-than-light travel.
Now, wormholes are still theoretical, but they are predicted by Einstein's theory of general relativity. The problem is they're notoriously unstable.
To keep a wormhole open, you need a form of exotic matter with negative mass, which is something we've never actually observed.
But let's say we could find a way to create and stabilize wormholes. The implications would be staggering.
We could travel to distant galaxies, explore the universe like never before, and maybe even travel through time.
Of course, there are still a lot of ifs and buts. But hey, that's what makes physics so exciting. The universe is full of mysteries, and who knows what incredible discoveries await us in the future. Chapter 9. String theory. The universe is a symphony of strings. What are the fundamental building blocks of the universe? Atoms, protons, neutrons?
What if I told you that everything in the universe, from the smallest particles to the largest galaxies, is made up of tiny, vibrating strings? That's the basic idea behind string theory, one of the most ambitious and mind-bending theories in physics today.
Imagine a guitar string. Depending on how it vibrates, it produces different musical notes.
In string theory, these tiny one-dimensional strings are the fundamental entities of the universe. And just like those guitar strings, the way these strings vibrate determines the properties of everything we see around us. One vibration might create an electron, another a quark, another a photon.
It's like the universe is a giant cosmic symphony with each particle playing its own unique tune.
String theory is still highly theoretical, and it's incredibly complex, requiring us to think in terms of 10 or even 11 dimensions. But if it's right, it could be the key to unlocking a unified theory of everything. A theory that explains all the forces of nature.
Chapter 10. The Theory of Everything. The Holy Grail of Physics. For centuries, physicists have been on a quest to find the Holy Grail of science, a single elegant theory that can explain everything in the universe, from the smallest subatomic particles to the largest cosmic structures.
This elusive theory is often called the theory of everything. It would be the ultimate triumph of human ingenuity, a set of equations that could unlock the deepest secrets of the cosmos and answer some of the biggest questions we have about the universe. What happened before the Big Bang? What is the nature of dark matter and dark energy? Are there other universes out there?
Finding a theory of everything is a monumental challenge. It would require us to reconcile the seemingly incompatible worlds of general relativity and quantum mechanics to find a way to describe gravity at the quantum level.
But the pursuit of this ultimate theory is what drives physics forward. It's the search for a deeper understanding of our universe and our place in it.
And who knows, maybe, just maybe, we're on the verge of a breakthrough that will change our understanding of the cosmos forever. Thanks for watching Top Thangs. We hope you enjoyed this journey through some of the most mind-blowing physics theories. Stay curious, and we'll see you in the next video.